Hi, today I'm going to discuss Semester 3 Mathematics for Computing 2 2016 Paper 1, rest of the paper, question number 16 to 25. Question number 16. Here we have to integrate the given function from minus a to plus a. So, we have to use some properties on even and odd functions. I'll be discussing that thing in the integration lesson. So here I am going to use the basic way of integrating x to the power k. The rule is when we have to integrate x to the power k with respect to the variable x, that is equals to x to the power k plus 1 over k plus 1. Then by using this you can integrate the definite integral by substituting the values given. Let's simplify minus a to plus a x to the power 5 with respect to the variable x. Then we have x to the power 6 over 6 from minus a to plus a. So we have to substitute the values x to the power a and we have to subtract when x equals minus a from that. When x equals a, we have a to the power 6 over 6. When x equals minus a, we have minus a to the power 6 over 6. This is also positive since we have an even index. So we have here a to the power 6 over 6 minus, here we have a to the power 6 over 6 same. So the result is 0. 0 is there in choice D. So D is correct. So the answer is D only. Question number 17. Find the second derivative of the function fx given. Fx is in terms of sin x and cos x. Sin 2x plus cos 3x is there. So we should be able to find the derivative of sin x and cos x functions. Sin x is cos x. Derivative of cos x is minus sin x. By using these two formulas, we can easily derive d over dx sin ax and d over dx cos ax. D over dx sin ax, we can consider this thing as capital X, then we have sin capital X. So when we find the derivative of that, you can consider the derivative of sin x, that is cos x. We have considered simple ax as x. When we replace that, the derivative of that one should be here as a multiplication. So the derivative of ax is a. In the same way, for this function, you can consider the derivative of the cos x function, that is minus sin x. So we have minus sin x. X has been replaced by ax. So we are writing ax here. At the same time, you have to multiply it by its derivative. So we have minus a here. When we find the first derivative f dash x, the derivative of this sin 2x derivative plus cos 3x derivative. So sin 2x derivative will be given by this. That is, the constant is 2, cos 2x is there. Cos 3x is in terms of minus sin x. So we have minus sin x is 3x. The constant is 3. Again, when you find the second derivative, you have to find the derivative of these two terms again. The difference is there. Then we can expand. 2 is a constant term is there. Again, the derivative cos 2x, that is minus sin x. X is 2x multiplied by its derivative. Then we have minus 3 as a constant. Derivative of sin 3x. Sin 3x is a cos ax form. Then we have 3 cos 3x again. When you simplify this, what we have is minus 4 sine 2x minus 9 cos 3x. That is there in choice D. So the answer is only D. Question number 18. We have to find the 29th derivative of fx. Definitely, we will be able to find a relationship between few derivatives. Fx is cos x minus sin x. Then the first derivative is equals to derivative of cos x is minus sin x. Minus sin is there. Derivative of sin x is cos x. When you find the second derivative, what we have is minus sin x derivative cos x minus cos x is minus sin x, then it will be plus. Third derivative of fx, minus sin is there, derivative of cos x minus sin x, with this minus we have plus sin x, plus derivative of sin x is cos x. Fourth derivative of fx, I'm going to find the fourth derivative since still we do not have any relationship between these derivatives. We have four different answers for f to third derivative. When you find the fourth derivative, derivative of sin x is cos x minus sin x. So this is same as f. So we can neglect this and we can consider this one as f4 as it is. Similarly, then f5 will be repeating this. This will be f6 and so on. Since we have to consider 29th derivative of fx, 29, we have 4 types. Then 29 by 4, that is 7 and remainder as 1. So when we repeat the same process, we will have f28 as the same function fx given. Definitely f29 will be the first derivative then. So the answer is minus sin x minus cos x, that is there in B. Answer is only B. Question number 19. By using this, we have to find in minus 1. So in minus 1 can be written as in terms of xn and ex when we are replacing n by n minus 1. Then we have x to the power n minus 1 here into ex dx. Since we have a multiplication of two functions here, you have to use the multiplication rule, chain rule, u dv over dx dx. If you have this, you can expand the integration as the multiplication of uv minus the integration of v u dash dx, where u dash is equals to du over dx. So we have to convert this multiplication into u dv form. Let's consider e to the power x as u. So here we have to have a function, then dx. How we can find this function? Basically that function will be the integration of the remaining function, that is x to the power n minus 1 dx. Integration of that is x to the power n minus 1 plus 1. For that we have to use this property. If you have x to the power k integration, that is equivalent to x to the power k plus 1 over k plus 1. So we have x to the power n over n. So the function here is 4v x to the power n over n. This is u. This is v. So by using this equation, we have the multiplication of u and v here. E to the power x over x to the power n over n minus integration of v. v is x to the power n over n, and du over dx is ex here dx. When you simplify this, what we have is e to the power x, x to the power n over n minus 1 over n constant, x to the power n is there, this derivative is equals to ex again, dx. We have this as I. So we can rewrite this in terms of in e to the power x, x to the power n over n minus 1 over n in. Since 1 over n is common for both, we have e to the power x, x to the power n minus in as the answer. That is there in A. So the answer is A only. Question number 20. We have to simplify the equation if dash x equals 0. So you have to find the first derivative of the function given, that is in the ln form. If you consider this thing as capital X, what you have is d over d simple x of ln capital X. That is equals 1 over capital X into the derivative of capital X with respect to the variable simple x. So basically what we have is d over dx ln of 2 minus cos x. That is equals to, when this is capital X, 1 over capital X is 2 minus cos x. You have to multiply by its derivative. That is 2 minus cos x derivative with respect to the variable simple x. So you can simplify this and substitute it here. We have 1 over 2 minus cos x into the derivative of 2 is 0, minus is there, derivative of cos x is minus sin x, then this will be positive again, then we have sin x equals 0. So we have sin x and cross multiplication gives that one as 0, because this is equivalent to sin x over 2 minus cos x equals 0. Cross multiplication. Here we have 1. So sin x equals 0. Sin x can be 0 at these points. When n equals 0, when n equals 1, when n equals 2, and when n equals 3, sin n5 values are 0. So we have infinitely many solutions that is there in C. So the answer is C only. Question number 21. You have 3 random variables. You have to identify the type of the random variable, whether it is categorical or numerical. To be categorical, definitely you should not have a meaningful difference for 2 values of the random variables. To be numerical, definitely you should be able to identify a meaningful difference. Suppose we have for the random variable x 2 values a and b. When you find a minus b, if there is no meaning for this difference, then x will be categorical. When you identify the difference as a meaningful value, then the random variable x will be a numerical random variable. So for the first one, BIT identity card number is the random variable. When you have two students, there is no difference between the ID numbers. We have a difference but meaningless. So it is categorical. When you consider the second one, the ideal rank, again, when we consider two students, suppose we have rank number 9 and rank number 5, the difference is, if you consider 9 minus 5, 4. There is no meaning for this. So it is again categorical. The time taken to complete a single transaction by a customer at an ATM. So if you have two customers, then if the time taken is A and B, so when we have A minus B or B minus C, there is a meaning for this difference. If this is the first customer, if this is for the second customer, when you have A minus B, what we have is the extra time taken by the first customer than B, if this is positive. Likewise, for difference of two values, there is a meaning. So, third random variable will be a numerical random variable. So, the answer is categorical, third one numerical, D. Answer is D only. Question number 22. Standard deviation of a binomial distribution. Binomial distribution means X binomial distribution of n trials and theta success probability. If so, the failure probability will be 1 minus theta. Standard deviation is 1.6 of success probability 0.2. So we know that theta is 0.2 and then 1 minus theta will be 0.8. Sigma is 1.6. So sigma squared is equals to 1.6 squared. Then in terms of n and theta, we can have a relationship between mean and standard deviation. Mu is n theta. Variance will be n theta into 1 minus theta. Otherwise, n theta q. Q is the failure probability. So sigma squared is known, 1.6 squared. N theta is replaced by mu. That's what we need to find. Expected value, also known as the average or mean. 1 minus theta can be replaced by 0.8. So mu is equals to 1.6 squared over 0.8. That is equals to 3.2. So answer is E. Only. Question number 23. If the variance of a Poisson distribution is 9, then its mean is. We know that if X follows a Poisson distribution of mean lambda, both mean mu and sigma squared variance is equals to lambda itself. Here the variance is equals to 9. So it is obvious that is same as its mean. So mean is equals to 9 at itself. Then the answer is C. Question number 24. 90% of the products does not have bad sectors. No defects. I'm going to consider D as being defective. Then D dash complement of that will be non-defective. A random sample of 10 tested for bad sectors and the number of hard disks with bad sectors in the sample is recorded. The random variable defined as X be the number of hard disks with bad sectors, with defectives. So you have to check each disk one by one. For each test, you will have one of two results, defective or non-defective. So you have only two choices, two results for each experiment, each trial. Then it will be binomial. So you will have one of these two answers. Directly you can neglect C, D, E. Yes, we have to do n number of trials, 10 trials, since we have 10 disks. The problem is what would be the success probability? You can decide it by considering the random variable given. The random variable is the number of hard disks with bad sectors. With bad sectors, that means you have to consider the probability of being defective with bad sectors. Probability of being a non-defective is 0.9. Non-defective is 0.9. If so, the required probability of being a defective will be 1 minus this, that is 1 minus 0.9 equals 0.1. So this will be the success probability. So you can identify the success probability will be varies from question to question. It will be highly depend upon the random variable that you define. So the answer is B only. Question number 25. The distribution of resistance for resistors of a certain type is known to be normally distributed with mean 6 and the standard deviation is given. But the cumulative distribution function of the normal distributed random variable, by using that, let's see how we can find the relevant probability. So, for the normal distribution given, you will have a graph like this. Since the mean is 6, it will be symmetric over 6 and the standard deviation sigma is equals to 2. By using this distribution, if you are going to find this probability, it will be the area under the curve covered by 4 and 7. If you shade this area, this is the required area for the probability 4 less than or equals x less than or equals 7. This is the probability density function. If you have the cumulative distribution function, it will be something like this. Then when you consider the cumulative distribution function for these two values, the relevant cumulative frequency will be the F4 and F7 by the y coordinates of these 2 points when x equals 4 and x equals 7. So by F7 minus F4 you will have the required area for the probability 4 less than or equals x less than or equals 7. That is the relationship between the probability density function and the cumulative distribution function. So to find this probability, the answer is F7 minus F4, that is C. So the answer is C only. Thank you for joining. See my next video for 2017 paper 1 discussion.